show that this function is order n squared log n. So to do that, we need to show that the following inequality holds, where t of n is less than or equal to c by f of n, for all n greater than or equal to n naught, where c and n naught are positive constants. So we can break this up into the following inequalities. So we have 2 is less than or equal to 2 by n squared log n. And this is satisfied for all n greater than or equal to 2. And we have 3n is less than or equal to 3n squared log n. And this also holds for all n greater than or equal to 2. And next we have 5n log n is less than or equal to 5n squared log n. And we can say that this holds for all n where log is defined. So that would be greater than 0. And similarly, n squared log n is less than or equal to n squared log n for n greater than 0. So if we add these together, on the left hand side we get 2 plus 3n plus 5n log n plus n squared log n. And on the right hand side we have 2 plus 3 is 5, plus 5 is 10, plus 1 is 11, n squared log n. And this equation holds for n greater than or equal to 2. So effectively, if we compare this with our big O notation, we have this function is t of n, and this function is f of n. So the constant c is equal to 11. So generally, we replace each term by a multiple of the fastest growing term, being n squared log n. Please subscribe, like and comment to help me reach more students.